All right, so I'm live with another language here. I'm going to play around with Rust for a while. So I have a series called 52 Weeks of Rust live stream. And I'm going to start with just the preface that I know almost nothing about Rust at all, other than the name Rust. Maybe I know Mozilla helped create it, and some people are using it for I guess kernel development from Linux. That's probably the gist of what I know. So I'm going to kind of follow things from a beginner standpoint, and each week just go a little bit deeper on what I can learn. So I'm going to go ahead and start here, and I'm going to share my screen. And so let's go ahead and set that up. Just give me a second to set up here. So I'm going to share. I'm going to have to come right back. Just hold on a second. Okay, so I'm back here. I had to just enable my screen sharing settings here, and I'm going to get set up again. There we go. Let's go ahead and share this window for Rust. Okay, so we got the Rust programming language, and I'm gonna swap things around so it's a little easier to see. Okay, there we go. And I think I'll also make this a little bit bigger of a window, probably like this. That looks pretty good. Nice. Okay, so I'm able to share my screen here and get started with Rust. And a couple things to point out here is that again, I know almost nothing about this, but I'm going to just read through the documentation. We got why Rust. It's very performant, reliable, uh, productivity. What can you do? So you can build command line tools, which I like. That's definitely I'm already excited about that. And we also can do WebAssembly, networking, embedded. So yeah, all these things sound pretty cool for me. And you can see there's people running it in production. So I'm going to go ahead and click on the get started guide here, which is probably where I want to start. Now, if I take a look here, you can actually try it out without installing. So let's at least take a look at that and see what this is like. Okay, that's kind of cool. So I can go ahead and run this, and we can see I can try Rust here in a browser. So that's I probably wouldn't necessarily use this tool that much, but it is kind of interesting that I can play around with it. Kind of a novelty here. But then if I go into how to actually get it working, I think what I'm going to want to try is the installation method. And so what I will try is I'm going to open up a couple browser windows here, and I'm going to really refer to this documentation while I'm actually going to GitHub code spaces. So for a web browser based environment, this is probably one of the ways that I would actually start experimenting with a new language. And so I'll go here and create a new repo, and we'll just call this 52 weeks of Rust, and trying out Rust. Here we go, trying out Rust. Actually, we should spell it right. There we go. Trying out Rust. Add a README file. Now for get ignore template, I'm assuming they have a Rust one. There we go. That's pretty neat. And I'll do Creative Commons. All right, so I've got the Rust here. That looks pretty good. And now what do I need to do? Well, I would say launch a code space. So I'm going to go ahead and configure an advanced code space here that is a large machine because I'm going to do compilation. So I want something pretty powerful in order for me to 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 be able to compile Rust. And once I've got that set up, now I actually can start playing around with the installation. So this will take just a second to wake up here, make this a little bit bigger, probably like that. And then also what I'll do is I will change the color theme so that it's a little easier on my eyes. Okay, so I'm in a new environment, and what I can do is just double check the installation method that they're going to ask for. And so if I go back to my docs here, notice it says run this command. Okay, well, let's try it out. Let's see what happens. Let's run this command here and see what this does. And I'm going to curl, and let's just even read what it says. It says, welcome to Rust. This will download and install the official compiler for the Rust language and its package manager cargo. Rust metadata and tool chains will be installed into the Rust home directory located at home, GitHub code spaces, Rust up. Okay, that's good to know. And this can be modified with the variable. And okay, let's proceed with installation. Let's just say yes. And this is going to go through here and get this thing cooking. Now, well, if we want to do something kind of fun, we can also run htop and just see like how much it's going to take in terms of processors. And this doesn't look like it's doing too much. So that was actually pretty quick. So Rust is installed, great. And you may need to restart your current shell, and this will reload the path. And so to configure your current shell, do this. There we go. If I type in Rust, what happens? Well, we don't know yet. We have to keep going down the road. So it says Rust updates very frequently, and one of the ways you can check it is by doing Rust up. Okay, well, let's try that out. And Rust up update. Okay, well, that worked. So we got another thing working. So Cargo is the Rust build tool and package manager. So when you install Rust up, you also get the latest stable version of the Rust build tool and package manager known as Cargo. And so if you want to build a project, that is neat. So you have a Cargo build, Cargo run, Cargo test, Cargo doc, Cargo publish, and then Cargo version. So yeah, let's make sure that we actually have it running. That seems like a good idea. Does that actually work? Okay, so we have Cargo. That's pretty good. And all right, so what if we want to just make a new project here, which is exactly what I want to do. So let's write a small application with our new Rust environment. To start, we'll use Cargo to make a new project for us. And so there we go. Let's try this out. Cargo, new, hello Rust. Here we go. So I want to clear my screen. Cargo, new, hello Rust. Oh, that was pretty easy. And let's see what it did. So it created a cargo.toml, which is a config file here. And we see some stuff in there. And then it created a source directory. And then there's a main.rs. So it makes a function called hello world. Well, that looks pretty intuitive here. So here we go. We see what the directory is. It created a source directory. And now if I type in cargo run, it'll compile. Let's do it. Let's go ahead and say cargo run. Ooh, wait. Oh, because I need to cd into that directory. Okay, let's do that. Cargo run. That was pretty quick. And let's see if I run it again. Let's see. Okay, so we got it running. Hello world. That's kind of neat. That's not too bad. Okay, so let's add a dependency. Well, that's always super helpful. In this project, we'll use a crate called Ferris says. In our cargo.toml, we'll add this. Okay, that's pretty useful. Let's go to the 2ml and dependencies. We'll swap this out. There we go. Ferris says, okay, what else do I do? And so it says cargo build. Okay, cargo build. So let's clear the screen, say cargo build, and it's going to fetch that third-party package. So far, so good. This is not too bad. Although that is taking quite some time. I mean, how big is this package? But that's a little weird. Well, I guess I can follow what it's going to say. It's going to say, so in this project, we use a create call for says, blah, 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 and this will install it. You'll see it running a command and creating a new file called cargo lock. To use this dependency, we can open up that file and just say, oh, remove everything that's in there and add this line. If this means that we can now use the say function for us. Okay, so I guess we're going to delete that other example and we're going to put this example in. So wow, I put a lot of stuff in there. Let's go back to here and let's just swap this code example out and let's see what it says. So we have use Ferris, which I don't know what it does yet. Use standard.io, and we make a new function called main, and we say let standard out. So this is interesting. It looks like F sharp a little bit, the let, or even Swift a little bit, because Swift has let, but we say let message, hello fellow Rustaceans, let width, let mute writer, standard out dot lock, say messages as bytes. Okay, well, what does this do? It says once we save it, we can do cargo run. Okay, so we've saved it. Let's go ahead and do cargo run. Here we go. Low. Oh, I guess it does some kind of really cool like visualization. Is that what it does? That's kind of cool. Let's see. So assuming everything went well, you should see this. So what does that do? What does this package do? That is interesting. Let's take a look at it. A library for printing out text with Ferris as the mascot. Oh, that's all it does. So it's kind of a I see. So it's text and then it wraps the text and has this mascot. Okay, kind of a toy little library. Okay, that's kind of cool though. And well, we have that set up. And so now let's go to learn more. And so what do we do next here? There's a book that's probably where I would start. And there's also, if reading hundreds of pages of examples isn't your style, let's try this out. Okay, let's do Rust by example here. So I'm gonna put this documentation inside of the README, and we'll just say like, trying to learn Rust. Here we go. And then we can say, yeah, this is probably more my style, like learn by example. Let's do that. We also could put in that we did do some Rust stuff, and we could say this, right? This was our Rust example. We go say like quick example. And if I go to the preview, there we go. Looks good. Learn by example, guide. We'll say learn by example, guide. That, and then I guess what I can do is I can just say get status and see that we can go here and just add the README, add the hello Rust directory. And if we say get status, what is it actually going to check in? That's so, that doesn't seem like we want to check that in, actually. That seems like we don't want to check that in. I thought I had a get ignore inside of here. That's not good. So that's one problem I have, is I'm checking in a bunch of garbage files that we don't want to check in here, even though I have a get ignore that's in theory supposed to ignore that. That is strange. Well, I could just say get rm-rf hello Rust. about that. And then if we say get status, just have the README. Let's do that. So I need to get a little better at figuring out how to not check in garbage. So I'll have to fix that. I guess I could put the get ignore in that other directory, but adding README, rest info. All right. So that's definitely something I screwed up on, was checking in things that shouldn't be checked in. But before I get too far down that road, let's just do a little bit more Hello World here. So this is a source code of the traditional Hello World file. In order to run it, you just you can basically say a binary can be generated by the Rust compiler by just saying rust c hello rs. Okay, let's do this. Let's start building things out here. So what I'm going to do is I'm going to um, and I think we don't, this hello rust should be gone actually. I don't see it anymore, at least. It's still there. Oh, it's a directory maybe. Its status. It doesn't even know about it. Well, let's just delete this. Let's just say hello rust. Okay, so everything's cleared out here, and I'm going to touch a file called hello.rs. So touch hello.rs. That's good. And then inside of here, we'll say this is a comment. It's ignored. This is the main function. So we can just say comment. Statements here are executed when the compiled binary is called. That looks good. Prints. So this is pretty intuitive. And I guess I could even put inside of here something like this. Like, let's do this. And then let's do this. Let's just show how I would actually get this thing working. So I'm going to say rest c hello. That compiles it. And then if I do dot hello, that runs it. Now, this again gets a little tricky, is if I say get status, annoying because I don't want to check a binary in. So that is something that I'll have to kick that can down the road a little bit, is how to not check in Rust binaries. I don't know yet. There's probably a way that people have a convention, but that's good. So we have comments. So we know that the double lines are the way to do single line comments, and then you can do a block comment, which is like JavaScript or lots of other languages here. So that's good to know. And then formatted printing. I see you can do print formatting here, which is pretty easy. It looks like. I guess I could try this out. Let's make another file here, and let's just call this hello prints. Hello p dot rs. And so all we need to do is make a main function again. And let's just get rid of all this. So let's see here. We got this. That's too much. We can just swap this out. So if we put in a square bracket, that will get swapped out with 31. Okay, that's pretty straightforward. And then I think we're missing the in bracket here. Yep, we're missing this in bracket. There we go. Now, one thing that I think I should do is I'm going to go over to my extensions here. And I forgot to do this, but let's go ahead and install Copilot. GitHub Copilot. we go. Your AI peer programmer. That's great. We got this thing cooking. And I'm curious if this will make me more productive in a language I have no skills in at all. Maybe. And let's try this out. So if I go here, is it, or if it's going to help me out or not? Maybe it takes a second to warm up. I don't see Copilot doing anything, but and if I do htop, I don't see anything running either. But let's go ahead and just get rid of that, and let's go ahead and compile it again, and we'll say hello p.rs, then hello p. Here we go, 31 days. Okay, I mean that's definitely pretty cool. That printing seems pretty straightforward to me. Not too bad. Now, what's next here is primitives. So Rust provides access to a wide variety of primitives. So signed integers, unsigned integers, bool, all kinds of different data types, arrays, tuples, and you can take a look at some of these here. I would probably say the best way for me to play around with this would be to, I don't know, play around with some of these. Like maybe, I guess this one is an okay one to play around with. So I'm going to go ahead and copy this, and I'm going to call this one primitive. Maybe that would be a good answer. So we'll say touch primitives.rs. Primitives, that looks good. And if I just paste this in here and take a look at what we've got. So we got variables can be type annotated. Okay, let logical bool equals true, regular annotation, suffix annotation, a default can be used. A type can also be inferred from context. And I'm assuming this makes this mutable. Mutable variable value can be changed. So this is a little bit different than Swift, where they have the ability to, they use a different keyword. And so let, I believe in Swift, is immutable, but then they use var, if I remember correctly, to be immutable. I could be wrong on that, but in this case, you say let mute to make it mutable. And it says the type of variable can't be changed. Variables can be overwritten without shadowing. Okay, well, so here's our primitives example here. Primitives. Ooh. So, oh, I see. Well, because this is an error. Well, we could just get rid of that. But it's good to see that the error actually worked the way I thought it would work. Unused variable mutable, let mutable, can be overwritten without shadowing. Okay, so it did compile, but there's a bunch of warnings because we have kind of play code here. But if we go to primitives, there's nothing we're doing with this code, but it is code that actually is in theory functional. And I guess it would be nice to have some kind of a cleanup here when you're compiling your examples. But that's definitely something I'm going to need to figure out, is now that I have a little bit of a feel for Rust here, as I said, probably my action item for next week is to figure out how to check in code without making a giant mess. I think that's probably one of the things to figure out, is how to handle source control, right? Because I don't want to be checking in binaries, but I want to keep these other files. So there's got to be some strategy that people use that is really kind of simple, and I don't know it yet. So pretty cool though. I learned a little bit about Rust, and I've got a long way to go, but I feel like I'm at least able to compile Rust code. All right, so that is it for me for today, and I will see you next week if you're around to play around with part 2.